Today we're looking at writing equations of lines now. So there are several different forms of the equation of a line. There's point slope form, which looks like this: y minus y1 equals m times x minus x1. This would be for a non-vertical line with a slope m that passes through the point x1, y1. Slope-intercept form is a non-vertical line with the slope m and the y-intercept is b. The equation of that line looks like this: y equals mx plus b. For a vertical line, that's a line with an undefined slope and an x-intercept a, the equation is just x equals a. Horizontal line is a line with slope 0 and a y-intercept b, and the equation of that one is just y equals b. And then finally, there's general form. Every line, all of these could be written in general form. With this one, the equation looks like this: ax plus by plus c equals 0. And for this, a, b, and c are all integers, so that means no fractions there. And generally, the a has to be greater than 0. All right, so now we're going to write the equation in point-slope form. So I have to use the point-slope form from above for the line that's passing through these points, 4, -3, and 2, 5. Wow, this is not the right picture for that. Anyhow, so we're going to write we're going to write the equation of, let's actually do the one that's on the picture because that'll be better. So I somehow got this point all wrong. So we're going to do -2, 6. There we go. All right, it'll be more meaningful if we can see the graph as well. Okay, so we're going to start in point slope form. So to do that, the first thing we need to do is figure out the slope because they didn't give it to us. So I'm going to use the slope formula, and then I'll verify it with the graph as well, just to make sure it makes sense. Just a glance at the graph there, I'm expecting this to be a negative number. So if I come up with something that's not a negative number, I'm going to check my math. So here we go. I'm going to call the second point over here point 2 and the first one point 1. So when I fill in the numbers, on top I've got y2, which is 6, minus y1, which is -3. On the bottom, x2, that's -2, minus x1, that's 4. And then I'll calculate from there. So 6 minus a -3, that's the same as saying 6 plus 3, so that would be a 9. And -2 minus 4, that would be -6. And 9 divided by -6 would be, let's see, the negative, first of all, I want to move it to the numerator. And 9 and 6 are both divisible by 3, so I would reduce the fraction by 3. So that would give me 3/2. So now I have my m value. I'm ready to write this equation in point slope form, which is what they were asking me for. So I'm going to write down what point slope form looks like. Y minus y1 equals m times x minus x1. And that's just from the chart above. So to use this, I'm filling in x1, y1, and m. But the y and the x with no subscripts, those are actually my variables, so they just stay exactly as they are. So I think I'm going to write down my equation here with just blanks. Okay, now I only need 1 point in order to use this formula, and I have 2. So for this, I would actually get to choose whichever one I want to use. So I think I'm going to use this one here. No particular reason. That's just the one I chose. So in this first spot here, I'm putting the y value from that point. So y minus -3. In the next spot, I'm putting the m value, which is the slope that I found. So that's -3/2. And then in the last one over here, I'm putting in the x value from the point that I chose. So that would be 4. And this is in point slope form. Now I could have used the other point and my equation would have looked a little different, but it still actually would have been the same line. I do want to simplify this a little bit here because I've got y minus a negative 3, and that's just a little bit messy notation there. So minus a negative is the same as plus, so I'm just going to change that to y plus 3 on this side. They did ask me to put it in point slope form though, so I'm going to leave it in this format. I'm not going to change it from here. Okay, the next thing they want me to do is to write the equation of the line in slope, intercept, and general form. So slope, intercept, and general. So two things to do here. So I'm going to start with slope, intercept form. To turn this into slope, intercept form, I need to, well, first of all, let's remember what that looks like. That's y equals mx plus b. And so to make this equation look like that, I'm going to just have to do a little bit of manipulation. So I'm going to go ahead and write down the equation that I had from my previous step. And then I'm going to simplify. So in the form that I want it in, there shouldn't be any parentheses. So I'm going to go ahead and distribute this negative 3 halves into everything inside the parentheses there. So negative 3 halves times x would be negative 3 halves x. Negative 3 halves times a minus 4 would give me plus. And then 3 halves times 4 would be 12 halves, which comes out to 6. Now also in slope-intercept form, the y is supposed to be alone on one side of the equation. So my next step would be to subtract 3 from both sides of this equation. So 6 minus 3 would be 3. Okay, so this would be my slope-intercept form. And if I go back and look at my graph, that would mean that the slope should be a negative 3 halves, and it is. And the y-intercept should be a positive 3. So where it crosses the y-axis is at positive 3, and it does. So my algebra makes sense along with the picture. Next up, I need to put this in general form. So this is the last one we wanted for this problem. So I'm going to write down what general form looks like. Oops. That's by plus c equals 0. All right, so to get it into this form, it looks like I've got all of my x's and y's on one side of the equation, and I've also got all the constants on one side of the equation, and it's supposed to say equals 0. Now, from the chart above, it also tells me that a, b, and c all have to be integers, which means no fractions, and a is supposed to be a positive number. So I think what I'm going to do is I'm going to take my slope-intercept form here, and my very first move is going to be, oops, that's supposed to be a 2. My very first move is going to be to get rid of the fraction. I think I'm going to fix that. That was not pretty. Okay, try again. 2. There we go. Okay, so to make this number here no longer a fraction, all I have to do is multiply by the denominator. Just the denominator. So I'm multiplying by 2 because that was in the bottom. I can do this algebraically because I'm doing it to both sides of the equation. And that's how algebra works. Whatever you do to one side of the equation, you just do to the other. So on the left, I'd have 2y. On the right, I'm distributing this 2. So a 2 times a negative 3 halves would be negative 6 halves. A negative 6 divided by 2 is just negative 3. And then I also have to multiply the 2 times the 3 that's over here. So that would be plus 6. Okay, so now I'm looking a lot closer to this general form now. The only thing I need to do from here is create a 0 on one side of the equation and make sure that the coefficient of the x is a positive number. Now, right now, on the right-hand side of the equation, I have my coefficient of x is negative. So I think the right way to handle this would be to add 3x to both sides of this equation. That would cause it to be positive, so it's going to save me a step there. Now the only thing left to do from there is to create a 0 on the right-hand side of the equation. So to turn the 6 into a 0, I'm just subtracting 6 from both sides of the equation. And that would not be alike with any of the terms that are over there already, so it ends up just being on the end there. And this is now in general form. Okay, I do want to emphasize something right quick. In all of these general form, or all of these forms of equations, there are equal signs in every single one of them. Frequently, I found that students seem to think that if there's an equal sign and just one thing on the other side of it, for some reason they just drop it off. But that's actually a really important part of the equation. So make sure you keep the equal sign and what's on the other side of the equal sign as well when you're asked to write an equation. Okay, next up, we've got horizontal and vertical lines. They want us to write the horizontal and the vertical line through a single point. So I'm going to do this, I think, by sketching a little picture. I'll sketch my picture down here. So here's a coordinate plane. I'm going to go ahead and plot this point. So negative 2, 7 would be, and I'm just kind of estimating where it is. And then, let's see, the first thing I want to do is draw, or write the equation of a horizontal line. So I'm going to draw a horizontal line through that point there. Now, according to what I had up at the top there in the chart, it says that the equation of a horizontal line is y equals, and then whatever the y-intercept is of that line. So if this point here is at negative 2, 7, and I draw a horizontal line through that point, where do you think it would cross the y-axis? Well, it would have to be at the same y value of that point. So y equals 7 would be my horizontal line. Let's do the same thing with a vertical line. So I'm going to draw a vertical line now through this point, negative 2, 7. And according to the chart up above, the equation of a vertical line is x equals, and then whatever the x-intercept is. So where would this one cross the x-axis? Well, that would have to be just the x value of that point. So that would be x equals negative 2. These are the equations of the horizontal and the vertical lines. So kind of a shortcut on that, if you're asked to write the equation of a horizontal or a vertical line, horizontal is just y equals the y value, and vertical is just x equals the x value. All right, so now we're going to write the equation of this line in slope-intercept form. Again, which form they ask me for is really important. I have to make sure that I write it in the correct form. So slope-intercept form. If you're feeling like you understand this, this might be a good place to pause the video and see if you can write this equation. I'm going to start off by writing what slope-intercept form looks like. And in order to write this equation, I would need to have numbers for the m and for the b. So if I can get those just from looking at the picture, then that's what I want to do. So for my slope, I can see on the picture that it is negative. It is falling from left to right, so I know it's going to be a negative number. And then I can also take two nice points from the graph and then count the difference in the rise and the run. So this is a rise of 3, and a run of 2. So this would be negative 3 over 2 for my m. Now for b is the y-intercept. And looking at my picture, I can see what the y-intercept is. It's 2. So I could just put in plus 2. And I now have the equation of this line in slope-intercept form. All right, now they want me to take that same equation, that same line, and rewrite the equation in standard form. So once again, this would be a really great place to pause the video and check to see if you can get this into standard form. So standard form looks like this: ax plus by plus c equals 0. And I need to make this equation look like that one. So once again, the a, the b, and the c have to be integers. So my first job would be to get rid of the fraction. So I'm going to write down the equation. And then I'm going to multiply both sides of the equation by the denominator. On the left, that would give me 2y. On the right, 2 times negative 3 halves would be negative 6 halves, which reduces to negative 3. And 2 times 2 is 4. And now I just have to move things around here. I want a to be positive, and a is the coefficient of x. So since x is over here on this side of the equation, and it's negative right now, I think I want to go ahead and move it to the other side. So I'm adding 3x to both sides. And then finally, I need a 0 on the right-hand side of the equation. So I'm going to subtract 4 from both sides. And once again, I'm making sure that I'm still writing that equals 0, because that is a really important part of the equation. In fact, without it, it's not an equation anymore. Alrighty, so there's one more problem on here. Again, if you're feeling pretty comfortable with this, then this would be a great place to pause the video and try doing all 4 of these parts here, A, B, C, D, and then come back and see how you did. All right, so time to check ourselves here. Finding the slope between the 2 points, slope of the line containing the 2 points, I got negative 2/5. And I just used the slope formula for that. When writing the equation in point slope form, there were actually 2 correct answers here because we had 2 points to work with. So we could have used this first one, and that would give us this one here on the left, y minus 5 equals negative 2/5 x minus a negative 5, or x plus 5 there. And if we had used the second one, that would give us this one over here. So y plus 1 equals negative 2/5 times x minus 10. Now, no matter which one of these you used, when you changed it into slope-intercept form, you'd get the exact same equation. So this one will be y equals negative 2/5 x plus 3, no matter which of those you use. Now, if you have trouble getting from this step to this step, this is actually a great way to get some extra practice with that. You could write both of those equations and then change them to slope-intercept form separately and make sure that you get the same answer. Okay, and then finally we had to write it in general form, and in general form, this is wrong. I made a mistake. That number should be 15. All right, there we go. Okay, so 2x plus 5y minus 15 is equal to 0.